Okay, so this is Mr. Great Tech Review in Mr. Great Tech Review Studio. We are here once again and we are live and direct. Today we are going to continue with our topic of Arduino Uno tutorial, and today we are going to download the IDE, the Integrated Development Environment. We are going to use the IDE to write our first program. We not waste too much of our time on how to download it, but it's very simple. When you go to Arduino website, you download it from Arduino website. So we can go to Google. So let me use I'm already downloading it on my PC. As you can see, I'm downloading it on my PC. It's going on my PC. Then I can show you it's going on the PC, and so I will just show you with the Mac so that you can see how you can also download the Arduino. So just go to Google. Go to Google. Okay, very simple. Yes, here is Google. You just write Arduino. Arduino download. Okay, here it is. Okay, so you see the first one is here, www.arduino.cc. so you click on it. Okay, so that is it. Okay, here it is. So you see the Arduino. Okay, so from here, okay, we use cookies. Okay, so let me make it bold so that okay, so you see Windows 7 and newer, Z files, Linux 8, Mac OS and newer. So I'm using Mac. Okay, as I can select on Mac. Okay, it says contribute and download. I've done that before, so I've done it with my tablet PC. So okay, now I will just say just download. I'll click just download. So you can see here it's downloading on my Mac. So that's very simple. So if you're using Windows, you can go to the window and you download the Windows version of it, the latest version of it. You're using Windows 7, 8, 10. You can also go there and make your choice. For me, I'm using Mac OS, so I just downloaded the one I'm making use of. So now, okay, we are done on my PC. I think we are done on my PC. So now I will go to open. I'll click open on my PC. Since I've done that, okay, it's opening. Yes, say allow. Okay, I will allow access. Okay, so boom, here it is. Here it is. So I'll bring it closer so that you can see what I'm doing. So it's open now. Let me shut down the Google. Okay, now you have it open in my PC. So as the Mac is still going, okay, let's use PC and launch our first program of Arduino. So before we go into the Arduino properly, we are going to, I know everybody must have gotten your starter kit, your most excellent starter kit, Arduino starter kit. So this will help you to do every practical. We are going to use this kit for every practicals. We are going to use this kit. So I have my Arduino here with me. I have my Arduino here. I have my Arduino board here with me. Okay, and I have my USB. Okay, so I have my USB, my This is normal type A, this type B, the printer cable. Okay, so I've been using this Arduino. Okay, so now I have my USB. I can keep this one side, keep it here with me. Okay, so I have my Arduino. I'll bring it closer. Okay, so I'll bring it closer. What is happening? I'm not receiving signal. Okay, I'm back. So now let's see our first program. We are going to write our first program on Arduino, but first of all, let's see how we can configure the Arduino. So you go to File. Okay, so you can see what I'm doing here. Okay, so let's go to File. You go to File, you go to Examples, you go to Basic, and you go to Bare Minimum. You click it. So Bare Minimum, this is where you write your program. You use Bare Minimum to write your program. Okay, so this is where you write your program. You use Bare Minimum. Okay, now let's also go to Tools. Okay, this is Bare Minimum. Let's go to Tools and see. You go to Tools. Okay, to make sure that your Arduino is set to Arduino Uno, because we are using Arduino Uno. So you go to Tools, you go to Board, you see Arduino Uno. By default, it's already set at Arduino Uno. You have Arduino Nano, you have Arduino Uno, you have Arduino Mega. So we are using Arduino Uno. So it's by default, it's already set to Arduino Uno. Okay, so now what again are we going to set? Okay, and okay, so let's connect our Arduino so that we can set the port so that our Arduino can be able to interface with the, so that our Arduino can interface with the system so that we can, two of them can be able to talk to each other. So let's connect our Arduino on one of the USB ports. And okay. You have heard the happy sound from the computer. Okay, let's go to Tools. You can see port. Okay, so Arduino is on COM3. So this is it, on COM3. You see it? So you have set your Arduino. So you click COM3. So for you to set your Arduino, so that you can be able to talk to computer, we'll be able to talk to Arduino. So you set it to COM3. So good, done. So, okay, Tools, once again, port, COM3, marked Arduino Uno. So we can remove it to see actually whether the system is recognizing it. So now we remove the Arduino. I can unplug it out. So you can see I can unplug it out. So see what I'm doing. Okay, so I can unplug it out. Okay, now let's go to Tools again. Okay, nothing is there, so it's not highlighted. So it's not highlighted. So immediately we plug the board. Go to Tools again. You see it's highlighted. Okay, so we can now be able to talk to our Arduino. Our Arduino can now, both of them can be able to talk to each other. The interface is okay. So now in our program, in Arduino program, we have, in our Arduino program, we have the void setup and we have the void loop. So, like the name appears, void setup, this is where you set your program, you set your port, and void loop is loop, repetition. This is where it repeats itself. Continuous, what you want the program to, how you want the program to run, the timing delay, how you want it to run. But on the void setup is where you set your port. It's constant, you set it. Port 1, this, port 2, this, port 3, output, port 3, input, port 4, this and that. So that is it. So we are going to write our first delay program. Our first program to turn the LED in pin 13 on and off. So you can see the LED in pin 13. We are going to turn it on and off. It's already on. And let's see how we can bring it. Let me use camera 1. Very close to camera 1. You can see this LED is already on. You see, it's on. So I've already used it before, so I've turned it on. So I will turn it off through my program, and also we turn it on back again. And now we can interface solid state relay and use solid state relay as our application, how we can turn it on and off using our solid state relay. That means the Arduino Uno will control the solid state relay, and the solid state relay will control our load. So that is very simple. So the first thing you are going to use, since we are going to use our pin 13, which is our output pin. I think in our last tutorial we have mentioned the functions of these pins, the pin 13, the pin 0 to pin 13, the ground pin, the analog pin, the power pin, the pulse width modulation pin. I think I've mentioned it before. I'm not going to repeat myself again. So you watch the previous tutorial to see the functions of these pins. So pin 13 is our output pin. So we are going to use pin 13 to demonstrate our on and off zeros and one program. We are going to write our first program. So we are going to write our first program. So we used pin mode in bracket pin 13. What are we going to use that pin 13? Is it an output, an input? We are going to use an output device, as an output pin. So we say output. So we write pin mode. So let's go and see how it goes. So pin 13. So now, so good. We are good to go. So we say pin mode, capital letter mode, M mode, pin mode. So you see the happy green, yellow to show you that you are right. You're on the right side. When you got it, you see it, it turns yellow. Okay, so pin mode is in bracket. Okay. Sorry. So bracket, you write 13, comma. Remember your comma. What's output? It's an output pin, so you put output. Output in capital letter. Output. So output. Okay. So it's green, showing you are correct. So bracket close, and you end it with semicolon. Semicolon, you put semicolon. So every program ends with semicolon. So now you come to void loop. Void loop. So you have written your first code on your void setup. Then you come to void loop. You write your second code, your void loop. So you come to this place. Now, what are we going to do to that pin? We are going to set it low or high. Okay, so like I said, my own is already high. So my pin is already high because I used it before. So I'm going to make it low and also make it high again so that we can demonstrate better. So, okay, let me go with high and later I'll do it low. So there will be no difference. Okay, I'll go with low first. So I will write digital right, small letter digital and capital letter W and rest the small letter. So I'll go digital digital, okay, right, okay, right. So that is it. Digital right in bracket. Which pin? Pin 13. Okay. Okay, comma, high. Okay, let's go. So we make it high. So remember, high in capital letter. High. Sorry. GH. Okay. Turn green. So you close your bracket. Then semicolon. Sorry. Semicolon. So that is it. So that is your first program. You turn it high. So now you download your program to Arduino. How do you download your program to the Arduino? Okay, let me show you. You download your program to the Arduino by clicking. Let's go and show you. You click this. You click this small button here. So that is how you upload your program. So this small button here, you upload your program to the Arduino. So we click it. Okay, yes, done downloading. So I'm going to look at it. The LED is still high, so it's on. Okay. Okay, so now let me turn it off. Let me turn it off so that you can see the difference. You can see the difference. Okay, now let's go. So now we did high. So let's do low. So I will delete high. I will type low. Okay, low. So low, I will upload. Okay, now I have uploaded. You can see it's off. Pin 13 is off. You might not actually see it. Okay, now we'll use an LED. We'll route an LED so that we can use an LED, a physical LED, so that we can be able to see the off and on of okay. Remember that the longer leg of this LED is the positive, while the shorter one is the ground. So the longer leg is the positive. So I will just twist a resistor. Twist a resistor. You have to be very careful because we are tapping direct from the board, so that you will not flash the controller. So that is it. So check ground. I have ground pin. Put my ground pin. Okay. Okay, so we go again on the program. So I'm going to make it okay, let's see how. Let me make it smaller so that we can be able to see both what I'm doing and okay, good. Now you can be able to see both of us now. Okay, you can now see what I'm doing, and let's go again with the program. Okay, so now let's go again with the program. Okay, it's better now. Okay, now so let's write hi again, and HIGH. Okay, and let's upload it again and see. So it's on low before. Let's put high again. Okay. Okay, now here it is. So you can see now the LED is on. It's on now. You can see the LED is on. So look at it here. You can see the LED is on. Okay, now if I go again and write low, and I'll upload, it will go off. Just watch. Off. Good. So I will write hi again. Hi. H. And I will upload again. It will come on. So that is it. Now you can see now low is off, high is on. So what actually happens here is that once you put low, so you are telling the program to shut it down, to shut the signal output of pin 13 to go to 0. So there will be 0 voltage. No 5 volts will not come out from the pin 13 again. So we have 0 voltage. It will be in the same potential with the ground. So you have 0 voltage coming out of pin 13, and the LED will go off. So once you program high, it will emit 5 volts, will just go out of the pin 13 of the controller, and your LED will come on. So why we use resistor is just to limit the current, because you know LED works with 3 volts. So we use resistor there. You can use 1 kilo ohms or 2 kilo ohms or 470 ohms, thereabouts. They can still work. So use to limit the current so that you will not flash the LED. And also you have to be very careful because you are tapping from the controller direct. So you have to be very careful because you are tapping from the controller. What actually is powering this is from the controller. So you don't have a shield. So like acts like a buffer, protection to protect the microcontroller IC. So you have to be very careful whenever you are tapping from the chip direct to power your LED. So that is how it works. Now we are going to add little delay programs, and we're going to add little delay programs. So our delay programs, we are going to add little delay programs so that we can see how we can run our delay program, and to make it on, off, and to add some delay programs. Okay, so now, so what will happen in this is, since it's high and we are wanted to come on, and after maybe 1 second is going to go off. After 1 second is going to go off. After 1 second is going to go off. So after 1 second, you know that 1 second is 1000 milliseconds. So give you 1 second. 1000 milliseconds give you. So the IDE understands millisecond. You cannot just put 1 there, and 1 means a different thing altogether. So you have to put it 1000 for you to have what is called so 1000 has to be with 1 second. That is 1000 milliseconds. So it works with milliseconds. So any figure you are putting there has to be in milliseconds. So 500 milliseconds means half a second. Half a second. So now we are going to write our delay program. So normally you come to your void loop. That is where you put all those ones. You have already set your pin. So to void loop with repetition, where you repeat, it's a loop. So in void loop is where you will set all these your delays, and you also know that for every delay you add, for you to be able to see actually what you're doing, you have to increase the figure a little bit. You cannot just put maybe you put a 50, you might not actually see it. So it has to be a sizable amount of delay so that you can be able to see actually what you are doing. So let's go and put a delay of 1000. That is 1000 milliseconds. So let's go and see the effect on this and see how it goes. So now, okay, now we put on this place, we say delay, write a delay program. Okay. Okay, now enter. So you write delay. So normal delay, you put delay. It shows you are correct. When you get it, you see the happy orange color. Delay, you put in bracket, parentheses, in bracket, you put 1000. So you close your bracket. You close your bracket and you put your semicolon. So now this is delay. So now you have written your first delay program, and how can this system see it? You say delay 500, 1000. So now delay, this is your first delay. So you put digital write 13 low. Digital 13 low. So let's go. Enter. Digital write 13 low. It's already high. So your delay is in the in between. So you write digital write pin number 13 low, so that you can be able to see the delay function, the delay program. So let's go. Now digital write it in bracket 13. Okay, comma. Remember your comma. Low. No. Okay. Okay, good. Close your bracket, semicolon, semicolon. Okay. So that is it. So you are now delaying by 1000. So now you say high, it delays low. So it's going to return back again. So it's a continuous process. It's not something that is going to come and stop. So you have to come again and say delay 1000 again. So say delay 1000, stop. Delay, okay, in bracket 1000, you close the bracket, semicolon. So that is it. So that is how it goes. Now we can now put it and see how it goes now. Now you watch this. We are going to send it so that you can be able to see. You watch the LED. This is the LED. So now let's see. So this is the LED. So now let us push and upload our program and see. Good. You can see it now. Okay. That is it. Okay. Have you seen? I've written your first program, your first delay program. So it's now blinking. So this is a blinking program. So that is it. So you can now alter the delay values, the timing values. You can put 500, 1000. Let's see how it goes. You put 1000, you put 500, 1000, and well, let's juggle with the delay program and see what we can be able to come out of it. Now, okay, let's go to the first one. Let's put 500, and let's upload and see. Okay. Okay, now the off is more than the on. So the off, you have a lot of lagging on the off, and the on comes on, it goes off and wait, and comes on again, goes off and wait. Now let's reverse the case and bring the 500 down and then put the 1000 up there. So let's go again. So both of them have the same equal delay, the same equal lagging, the same equal leading, lagging, the same thing. They are on the same page. Now let's bring and write 500, bring 500 down. Okay, now let's go 500. 500. That is 500 milliseconds. Okay, let's see. Okay, here it goes. Okay, I think you notice the difference. Let's bring it down again to, let's bring it down again to 200. 200. Let's see. Okay. 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 Hope you can see. This is 1200. 1200. On the low side, you have 200. On the high side, you have 1000. So it's still longer on the high, and low is still less. So you see it. So on 1000 we have you have the high. Then on the low we have 200. So let's make the low 2000, and let's see. That is 2 seconds. 2000. So let's see. Okay. Now let's upload it and see. Okay, sorry. Okay, let's upload it and see. So I have 2000 here. I have 2000 here. Okay, now let's upload and see. Okay, so you see on the low now, you have more delay on the low, which is the off time. You have more delay on the low, which is the off time. As you can see, look at it here. The off is more, which is 2000 milliseconds, which is 2 seconds. So that's why it goes off for a longer time before it comes on. So on is 1000, while the off is 2000. So you can see, you see it? That's how it works. So it is very simple. Coding is very simple. Arduino coding is as simple as A, B, C, D, E, F. So it's very, very simple. So with this few knowledge, you can be able to proceed and do more, and you can be able to juggle with the timing and see what you can be able to come up with. But in today's, I'm going to add a little flavor to what we have done today. We are going to remove LED. Today, we are going to remove this LED, and so we are going to remove the LED, and this LED, we are going to remove it. We are going to add a solid state relay, and with the solid state relay, we are going to interface our energy bulb, our load. So now we can now see how this can be transferred to the solid state relay, and from solid state relay to our load. Now this blinking will come on with the load. Our energy bulb will doing prom, 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 prom. So we can be able to see it clearly now. Now you have transferred your program to application. Now you have not applied it. Now it's no longer LED. You are now applying it. We can do the same with contactors. You can use contactors and do the same. We can also use we can use contactors to do the same. How it can on and off contactor. So now what we are going to do, before we have timers, you use timer, this type of timer, to do your delay program. You see how cumbersome it is. Very big, very big, very big as this timer, occupying space in your electrical panels. But with small Arduino, look at this small thing here. The small thing here, you have already run your program. You can run the, and this is the maximum this can give you is 60 seconds. This is the maximum you can give you. This big timer is only 60 seconds. But with Arduino, you can incorporate a delay program and still add. It's only one port. We are using only one port, just a small program in just one port. One port out of the ports, 13 ports we have here, we're making use of only one port. So now we use only one port as a delay program. So we can use it to do so many things, and instead of you occupying space in the whole panel, with this panel, a lot of things, you have a lot of space, you have a lot of features to add to your electronic and electrical configuration as far as electrical control is concerned, electronics control is concerned. So that is it. So now you can see, now we are not making use of this timer to achieve our delay program. We're now using Arduino Uno to achieve a delay program, and we have seen it live and direct here. So okay, now in the next section we're going to use all of them so that you understand the difference. They are still good. The delay timer is still good. We still make use of them today. It's not everybody that has the knowledge of programming, and the process of programming and rigorous exercise is somehow, it's not, the knowledge is not applicable to everybody. So now we are going to make use of all of them. We are going to use our momentary switch. We are going to use our contactors in just this same delay program. We are going to apply it immediately. So anyone we achieve, we apply it. That's how we are going to be doing it in this our tutorial class. Let's apply it and see, apply the solid state relay so that we can be able to move along. Let's add the solid state. Okay. Okay. Now here we go. Now we are on the practical section. I have my board with me here. I have my board with me here, and I have still Arduino, the Arduino board still blinking back here, and I have the solid state relay. You can see this is the solid state relay. You can see the solid state. This is a solid state relay, and I have this as my input. This is where I have my input. This solid state relay works with This one, they said, is from 4 to 32 volts DC. So if I apply 32 volts, it will open. 4 to 32 volts, it will open. So you can see the red light. So this is 9 volts I'm applying. So what actually happened is that if you apply a voltage on this 2 pin, plus or minus 32 volts, it opens here, it closes here. So it latches here latches, here closes. So that is what actually happens here. So it closes here. So once you apply 42 volts, once you apply a voltage from 4 to 32 volts, it closes here, here closes. This 2 pin closes, which is pin 1 and 2 closes, and this 40 amps. Normally it's solid state, it has to work with heatsink, so you have to apply heatsink, but the load I'm applying on it is just a very small load, so I don't need heatsink. So this is how it works. Now this is my load and this is my supply, and this is my supply. Sorry, I'm bringing my supply. This is my supply. I have my live, I have my neutral. I have my neutral goes to the neutral of my load. This is my bulb. Okay, and this is it. So I have my live. If I go directly on it, my light goes on. So what I'm going to do is that I'm going to use these two as my switch to make or break contact so that I can power this. So let me go directly so that you understand what I'm talking about. So let me go directly. So you can see, so that is it. So now we are going to interface it with this solid state. So now, okay, so let me make my connections. I connect this to this and this to this. So very simple. I connect one leg of the load to this and the other leg goes back to the supply. That is how I'm going to do it now. And let me unplug it so that to avoid electrocution. So now this leg, I'm gonna connect it. I'm going to connect it. Okay, be careful because it's live wire. So now it's not powered yet, so I can touch it. I can make my connections. You can see what I'm doing. Okay, I can make my connections and then okay, now let's see. Okay, done. Now, so this is it. Remember, my Arduino is still on. My energy saving lamp is here with me. Okay, in such a way that you picture everything together. Okay, good. It's good like this. So this one is good. So I have this. So if I supply a voltage on the solid state, what happens is that it will make contact from this to this, current flow from this to this, and my lamp comes on. So this same voltage is what I'm going to use Arduino to supply. So to show you that you can use Arduino to control solid state relay. So the same thing, just to show you that if you apply a voltage on this end, it makes contact, makes a contact from number 1 to 2 and the lamp comes on. So let me connect and so that you can see how it goes. So now what you are seeing now is just you have okay, you see it? This is how it works. You can see it now. My Arduino is now controlling the solid state relay. Let me picture it very well so that we can be able to see it. So it's still the same program. We are still on the same program. So now the delay, you can see the delay time as we have in our system is on the low side we have 5,000 milliseconds. On the high side we have 3,000 milliseconds. So now I'm using Arduino now to control my LED. Now you can see Arduino Uno board is now controlling the LED. So that is it. So these are simple practical applications. You can use the delay timer in Arduino to delay your delay programs in Arduino to do a lot of things like this. It's controlling. You can put a buzzer. You can be doing bing, 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 depending on whatever load. Now this is the solid state relay working with the Arduino. So it's very simple. So whenever it comes on, it's the LED, the light bulb comes on. Look at it. It's on. It's the same thing. Okay. Very simple. Okay. Comes on. Goes off. So that's Arduino program controlling the load. The 220 load. So this is 220. Okay. Okay. Now you can be able to see how it works. Okay, so this is it. Okay, now we can remove the 220 light bulb. We can put contactor and see how it is same thing. It goes the same thing with the contactor. This is where the bulb is coming on. So we can now change the program. Now let's go to the system so that we can be able to change the program. Let's go to the system so that we can be able to change the program from the system. So now let's go back to 1000 and see, so that you can be able to see that it's actually the system is the Arduino is controlling this light. So let's put 1000 and let's upload and see. Let's put 1000. Let's upload and see. Yeah. You can see it. You can see it. Good. Good. Okay. Now this is 1000 on the low side and 1000 on the high side. That is 1000 milliseconds on the high side, 1000 milliseconds on the low side. That is 1 second on the high side and 1 second on the low side. So you can see the wonders Arduino is doing. We are just live and direct. Anyone we achieve, we do the live application, the live practical application of it. So you can see it. So it's not something. So let me raise the camera very well so that you can see the bulb blinking. So that is it. That's Arduino. So now we can incorporate contactor. Let's put contactor and see how contactor works with this. So now we are going to put contactor and see how contactor works with this. So I'm going to remove the LED. I'm going to remove the LED. I'm going to remove the lamp. I'm going to remove the lamp. So now this is the A1. This is the A1, A2. Look at it here. A1, A2. So live and neutral of this contactor. So now it goes like this. Okay, the live, I complete it like this. Now the neutral goes to the supply. This is my supply. This is my supply. So it goes to the supply. So I tighten it up. Okay, so that is it. So now we are good to go again. So we are going to put our mains on so that current will flow from here to here and get to the contactor. You see, this contactor will be jumping on the same program with this, with the Arduino program, with the delay program in the Arduino. So now let's connect and see how it goes. Good. You can hear the sound. Look at it. Comes on. You see it? Comes out. The same program. Okay. This is Arduino working. Okay. 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 Now let's reduce it to 100 so that this contactor will jump, we dance. Okay, let's do 800. On the low side we have 100, on the high side we have 100, 100, 100. Hundred. Okay, let's upload. Okay, you can see it. That is Arduino program for you. Very simple. Very, very simple. So whatever program that is in the Arduino chip has been transferred to the solid state relay, and from solid state relay gives the command to the contactor. So it's very simple. Arduino is free in the internet. Download the IDE, buy the Arduino in the market, get yourself the training kit, and come along and let's explore the world of technology, the world of tech. So it's very simple. So it can see. So whatever program that is in the chip is being transferred to the power device and to the contactor, which will control the power. So anything you connect to this contactor now, if you connect any load on this contactor, you still see the same effect. So even if it's a lamp you connect it to this contactor, you still see the same. Okay, thank you very much for paying attention on this our tutorial today. As you can see, we have covered a lot in our Arduino program, and we used contactors, solid state relays. Use our contactor, our solid state relay, and we use what again? We used our lamp. Okay, and we also made use of buzzer today to experiment, and with the LED light emitting diode. You can see the light emitting diode is very small, very tiny. The light emitting diode today. So we have covered a lot today, and all of them is free of charge. I'm giving it to you free of charge without you paying one kobo. So without you paying a dime. So now you help me to do something to get yourself this. Get it from Amazon or from AliExpress. Is very cheap, $45 to $50. You can get yourself this, so that in the subsequent tutorial you can be able to flow along with me. So that is it. That is the only thing you help me to do for yourself, just to get this training kit, so that you can be able to flow along, so that we can dive into the world of tech using Arduino to do wonders in the field of electrical electronics, just for control. Just like I said before, Arduino is used for control. It's used for control, that nothing else. That is just for control, for electrical control, electrical electronics control, to control electric motors and every other load you can think of in the field of electrical electronics. And once again, we are calling it a day for today. This is your one and only Mr. Great in Mr. Great Tech Review Studio, bringing you live and direct practical Arduino tutorial. God bless you. See you next time on our Arduino program. Okay, bye-bye for now.